Hello everybody, welcome back to Modern Dentures. In this video I want to talk about 3D printing. We do 3D printing in the laboratory, and we're also looking at going for a full workflow with the 3D printing in terms of printing dentures and things like that. Something that we're looking into at the moment. But I did some 3D printing at home on my little Bamboo Labs A1 printer. It's a really great little printer, it's so easy to use. What I needed was these. We got these base plates which are for the Stratos articulator, and over time the problem is the magnets in there, they rust and corrode, and then you can't use them. So I was looking at buying some more. I need a whole load of them, but they're £50 each, and I was looking at it, I was thinking 50 quid for that just seems like a lot of money. Obviously all the tooling and everything involved to make these, but then I thought, well, they could just 3D print them because it would be really easy. It's just a inset screw and a magnet, and then the rest of it is, this is probably injection molded to give it the strength. But I thought, well, I'll have a go. I'll just 3D print my own slightly different design, and but in some ways better, because I've done it so that this magnet just pops in. It's a sort of standard size 20mm, 25mm magnet, 2mm thick, which wasn't thick enough actually. I had to put 2 in there, so I made it twice as deep. I put 2 magnets in, they just push fit, they're not glued or anything like that, literally just pop them in. And these magnets fail, we could just pop them out, put some new ones in. But to be honest, this cost like pennies to print. It doesn't cost hardly anything for this filament. You know, maybe £1 or £2 to print that, as opposed to £50. And you know, if you have to buy 10 of them, that's only you're gonna use that for like 5 Arctics, because you need 2 for an Arctic. It's like 500 quid. This is going to cost me like a tenner. So this is version 4 or 5. So I did various different ones the way I printed. So I had them thinner originally like this, with the structural sort of element to them. But obviously this material is not as strong as this material. However, this is more disposable. So if this gets ruined, we can just throw it away and print another one, and it will probably end up maybe costing us more money over the long term. I don't know, depending on how long they last. These I've had for years. But if you do wreck them, like this one, it's been put through the model trimmer by the look of it. It's got a bit shaved off of the back. Whereas this, if it happened, you shaved a bit off, I'd just throw it away. I'll just print another one, buy you another pack of magnets, and we're good to go. The little locators have been done slightly different to there, as it's thicker because of the strength of this isn't as strong as that. So the infill in there is sort of like give it its strength, but the principle is exactly the same. Now this one I haven't set it up, so we've got some little inset screws. You get them for the 3D printed material, and all you do is just heat them up, get them really hot, and then you just push them into the hole, push it flat, it goes in. And then when you put it on the Arctic, I mean these, because I've done them to the exact size, you could probably not even bother screwing them on because they're really tight, which is good because there's no play. So when you're working on it, even with these ones, when they're screwed in tight, you can get like a little bit of play. Probably not for new ones, but because I've had these like probably 15 years. They've got a bit worn out, but these ones are really tight. It's just PLA, so it's just a cheap material. It's not like it's not one of the carbon fibre ones or anything like that. But that would have been better. And I'm looking at getting the new Bamboo, the latest one. It's an enclosed one, so the whole unit heats up, so you're able to print the stronger construction materials, things that are more water resistant and stronger, set harder because they have to melt at a higher temperature. But yeah, I wanted to share that because I do quite a bit of 3D printing, not just in the laboratory for all the things that we do in there, but I do a lot of 3D printing at home as well. It's usually jigs that I do, or I make like little clips and fasteners or little boxes for storing things in and keep them super organised. I thought, why don't I just try and print these and see. And it's worked really well. The guys have started articulating with them and they said, yeah, they work really well. The only problem, they said, is that they're a bit thick. So generally when you're articulating, you need to be quite high up with the top model. So if you've got a big chunky model, it can be quite difficult to get it high if you've got these. But in that case, we've still got some of these, so we can always use those at the same time, revert to them. Yeah, and actually the magnetation on them, magnetation, is that the right word? Magnetization? I don't know. The magnets on them are actually a bit stronger than these ones. Although these are stronger magnets, because we've got two on there, when we're articulating, rather than just putting a piece of steel on there, which again goes rusty, but rather than just putting a piece of steel on there, we put a couple of magnets in the plaster side. So you've got a much stronger force which is holding it in as well, which is nice when you're working on it. That, you know, the last thing you want is for the magnets to keep slipping off. I'll be keeping an open mind about what we can use the 3D printer for in the laboratory, and if I come up with any other great ideas that can be useful, that you guys might find useful, then I'll let you know. If anybody else is interested in this, by the way, I'm quite happy to share the file that I've got for it. Hope you enjoyed the video. I will see you in the next one, and don't forget to like and subscribe and that. Cheers. See you later. Bye.